Hello, physics friends. All right, guys. So today we will be working on problem 2 from the week 2 group works. So, in this problem, we have this screenshot, or how I call it, or a moment shot diagram for a wave travel. Now, the problem states, draw a snapshot. Oh, actually, no, we have a history diagram. I'm so sorry, my friends. We have to draw a snapshot graph for a time equals 0.03 seconds from the following history graph for position x equals 1.5 centimeters, assuming the wave is traveling to the left at a speed of 50 centimeters. Now, if you notice, we labeled this as part 1 in our video tutorials, so we will go to part 2 because of lack of time. So to begin, we need to figure out a few things. First, let's simplify this curvy graph into a more stick figure type of graph for my art skills. As you can see right here, we're going to just be focusing at the main points, 2.5 to 1/2, 1, and 0.5, all of them being in the negative side. Now, what do we need to know? We need to know if the image needs to be mirrored, what is the pulse width, and the starting point for this graph. So we're going to first assume that we're going to be working off this diagram at time equals 0. In part 2, we'll talk about how we will shift it into the time equals 0.03 seconds. Now, what do we know to help solve us for these three things? The pulse width is traveling to the left. The pulse lapse is about 2.5 seconds. And the velocity is about 50 centimeters per second. The starting point also happened 2.5 seconds ago. So that happened into the past. So with the pulse traveling direction, the middle rule will not apply since it will be traveling in the left direction, so no mirrored image. The pulse width can be found by using the pulse time lapse and the velocity, calculating those by multiplying by each other to cross out the seconds and the time units. We will be left with centimeters and getting 125 centimeters or 1.25 meters. We will use our drawing in units of meters. Now, for the starting point, we also have that it happened 2.5 seconds ago. That also gives us 1.25 meters, and it will be starting. So that basically means the starting position is 1.25 meters from the origin, and since it happened in the past, it will be on the left side from the origin. Now we can start drawing with that information. Our starting point is going to be 1.25 meters, or negative 1.25 meters. So we'll have a little dot, as you can see right here, is where our starting point will be when time is equal to 0. Now, our pulse width, we also know it's about 1.25 meters wide, so that'll happen right at the origin. Now, we will have, since we know that it's not going to be mirrored, and so we'll be looking at the same type of image, we can put a few dots for contour to figure out what our shape is going to look like, and kind of understanding that every half a second is going to be equivalent to 25 centimeters or 0.25 meters. So we can move every 0.25 meters and figure out where those other amplitude points are. Now, fill in these lines or connect the dots, we can get our snapshot diagram off of this. Oh, battery's going low. Off of this diagram, but this is at time equals 0, not time equals 0.3. Stay in tune for later in the week where I will show how we shift it. If you want to know a quick hint, you just basically shift the diagram the distance of the time. So since we're multiplying 50 times 0.03, it's going to be 15 centimeters that we're going to shift to the right. I'll show you that tomorrow. Anyways, hope this helps you guys, and hope you have a good night. These socks are amazing.